everyone. Thank you for joining me for my talk, Smatterings of F#. My name is Matthew Watt, and I'm a software engineer at Omnitech in Sioux Falls, South Dakota. This talk centers around one question. What's your itch, and how can you scratch it? What's that thing that you love to do? What's that technical topic that you could talk about for hours? When you're bored or burned out, what refreshes you? Over the last 2 years, I realized how important this question is to me, and I'll tell you how with a story. At the beginning, my answer to what's your itch was mobile apps. I was in middle school when my brother-in-law, Ben, got the first generation iPod Touch. I remember being blown away by how cool the apps were. And even more amazing to me was the idea that you could make games and apps like that from code. From then on, I was hooked. My fascination with mobile apps was what inspired me to pursue my computer science degree, to learn how to build iOS apps, and all of that eventually landed me my first full-time job as an iOS developer with Panera. My itch became a dream, which became a reality because I was determined to scratch that itch. But then things changed. After a couple of years of working that dream job, I lost the itch for mobile apps. Now, don't get me wrong. I don't think that's how it shakes out for everyone. Some people land their dream jobs and love it for their whole careers. It's just not what happened for me. For me, I think there was something about understanding the magic that made the magic fade for me. But ultimately, that the magic faded wasn't my problem. My problem was that I didn't go looking for my next itch. Instead, I spent the next 3 years jumping through 3 different jobs and being generally miserable. What motivated me was mainly money, either directly or indirectly. One job I took because I thought it would help me to scale up and make me more marketable for future jobs. Another job I took because it would allow me to be remote and move closer to home, which would lower my cost of living significantly. And the other job, my current one, I initially got because I wanted to add C# and dotnet to my skill set. Again, because I thought it would help my future earning potential. But everything changed when I finally discovered my next itch. F# and functional programming. Now, it might sound over-exaggerated, but I'm not kidding. Functional programming and F# re-sparked my love of coding. After my fascination with mobile apps faded, coding was just drudgery. It was a day job. Every day just felt like more of the same. But functional programming opened me up to completely new ways of thinking about code. It has taught me how to think and be critical in ways that I hadn't before. But most importantly, it gave me something to pursue and move towards. Now, even when things might not be the best at work, which happens at any job, I have something that I can dive into that refreshes me. I have a topic that excites me and drives me to keep growing and learning. And it's even motivated me to become a teacher and speaker. It's why you're watching this video right now. So, I've told you a little bit of my story. Now, I want to show you what I've been doing to scratch my new itch. First, we'll look at my blog and some of its source code to see how I use it as a playground for writing F#. Second, we'll take a look at some of my open source contributions, mostly to F# projects. Contributing to open source is a great itch-scratching tool because it's an opportunity to get involved in projects that you might otherwise be able to be involved in. And within the .NET ecosystem, there are tons of great open source projects to choose from. And as we'll see, you don't have to do a lot. Start small and go where your itch takes you. Now, because we only have a little bit of time together today, this will be a high-level overview, and I have a few goals. 1, I hope to inspire anyone watching this to find your itch and scratch it. Let it motivate you and drive you forward. 2, I hope to encourage my fellow F# developers. C# is my day job, like many of us, but I still find ways to scratch my F# itch, and I'm a better engineer for it. You can do that too. 3, I hope to pique the interest of any C# developers who are watching. I hope that even just a glance at some of this F# code gets you curious about functional programming and F#. Learning, applying, and teaching F# and functional programming has made me a better C# developer, and it can do that for you too. So let's jump right in. So here's my blog. It's a pretty simple site. We've got my landing page, which displays just the most recent post. Then we've got some navigation here at the top, which will take you to the rest of the site, which is pretty much basically a listing of all the posts, and then you can browse by category if you want. And then I also have a bio section that tells you a little bit about me. Nothing groundbreaking here, pretty standard blog. Originally, I built this as a custom Next.js site, which worked okay. But then one of my coworkers told me about Astro. Now, if you've never used Astro is a web framework for content-driven websites, which means that it's perfect for a blog. So, after only posting essentially one blog post on my Next.js version, I migrated that site to Astro. It's much nicer now because now instead of writing my blog posts as React components like I did before, I can write them as markdown files and they automatically integrate into the rest of the site. The other really nice thing about Astro is that it allows you to bring your own components. They have support for UI components from most of the major front-end frameworks out there. And this is great because it means that I can write components for my blog in F#. And I can do this because I have access to 3 specific tools. The first one is Fable. Fable is a really cool project that allows you to compile F# code to JavaScript and a number of other target languages. If you've never heard of the Fable project, I highly recommend that you check it out. It's really cool and really powerful and allows you to build full-blown, full-stack F# apps. The second tool is Felice, which provides F# bindings to the React APIs, which means you can write React components in F#, which is exactly what I wanted. The third tool is a Vite plugin for Fable. This enables Fable to integrate nicely with Vite tooling with all of the nice modern web tooling that gets us. So, enough gab about the tools. Let's see what parts of my blog are written in F#. Now, when I started trying to think of components of my site that I could write in F#, the first component that I thought of was the support section. Every legitimate blog needs a support section, right? So that's what I decided to do. So let's quickly see if we can find a post. And let's just do this one, for example, since it's nice and short. Now, if I scroll down to the bottom here, we will see my support component. It's a very simple selection layout that allows you to choose your favorite crypto and support me if you feel so inclined. I did it this way for 2 reasons. The first one is right there in the UI. I think ads are gross, and I wanted to give people choice and not shove ads down their throat. The reason it's crypto is because I've done some open source work with the crypto community, so it kind of felt fitting. And it was also a pretty simple setup. The next component that I wrote in F# is a PDF viewer. After the last conference that I talked at, I had a lot of folks ask me for my slides, and I could not for the life of me figure out how to get them uploaded to Whova. So, as a workaround, I decided that I would quickly throw them up on my website. So I pulled in a PDF viewer component, wrapped it as an F# component with some custom themed controls, and bing, bang, boom. People can peruse my slides just by clicking through them, or they can download them right here. And I think that's pretty nice. Now, the most recent component of my blog that I wrote in F# is the most significant, and it's my comments section, as you can see right here. So, I know that you can get out-of-the-box components for something like this, but where's the fun in learning in that? So, to incentivize myself to write a bespoke comment section in F#, I signed up to give this talk. And because I'm in front of you right now, I had to get it done. So here's a quick overview of how it works. You enter in your email into this field here, an optional name, and your comment. If you've never posted before, you'll get an email with a verification link, and once you've clicked the link, you'll be brought back and you can post your comment. Now, that doesn't mean that your comment will show up right away, because I know how the internet works. So I decided to add some simple moderation capabilities. When a comment gets posted, I get a push notification to a custom Android app that I wrote using Claude and GitHub Copilot. From there, I can approve or deny your comment. Now, I know that spammers always find a way, so we'll see how long this scheme works for me, but initially my goal was to keep it simple. So now that we've kind of had a high-level overview of the end user experience for some of these F# components, let's take a quick look at the code. This won't be a deep dive due to time constraints, but I hope to give you a little taste of what F# can look like for real-life use cases and inspire you to go out and give it a try for yourself. Let's take a look at the front end first. So I have my project pulled up here, and as you can see, the F# files just live right next to all the other files in the project. The only thing that you have to have is an F# project file, which we have right down here, if you can see that. And you have to have some configuration code in the astroconfig file, which is all documented in the Fable plugin website. Now I have some utility code here at the root of the project, but the most interesting code here is in api.fs. So let's open that up quick and take a look. This file defines everything needed for my comments component to interact with my backend server. We define all of the request and response objects as F# types here. Then we have a module that contains functions for each of the API endpoints. One to get comments for a specific post, one to submit the commenter's information for validation, and the third one is to post a comment once you've been verified. It's only in total about 75 lines of code, which is one of the typical bragging points of F#. It's very simple and concise. Let's take a look at the UI components next. So if we open up components and then widgets, we will see some F# files. Let's focus in on the comments component since it's the most involved. Up at the top, we have some types defined for writing an Elmish component. Elmish is an architectural pattern that's pretty common in functional programming. It was first popularized by the Elm programming language, hence the name. For Elmish components, you need 5 things. First, you need a type defining all of the events that can happen in your UI, which we have right here. Then, you need a type to define the state of your component, which we have right here. Then, you need an init function, which returns the initial state of your component. That's what we have right here. You also need an update function, which handles events and returns new state based on those events. And then finally, you need a view function, or render function, sometimes called, which renders your UI based on the current state of your component. If you've ever used Redux before, this should look pretty familiar. Both of these things are based on the same fundamental principles. Now, the most interesting thing about this code, I think, is the use of the react.useElmish hook. What this lets you do is write a React component that uses Elmish for its own internal state management, but from the outside, it's just a regular React component. This is really nice, especially for a situation like mine, where I don't need the entire application to be Elmish, but I do want to be able to plug in useful components here or there. And that's really it for the front end. So let's jump into the backend code. So I have my solution pulled up here in Writer, and there are 3 main projects. The first is core, and the second is core API. In functional programming, there's this idea of architecting applications as a functional core with an imperative shell. This is where all of our business logic is encoded as pure functions that are simple, composable, and easily testable. Then, at the edge of the system, we have the shell, where all of the side effects like reading databases or calling external APIs happens. And that's what's going on here. I divided them into their own projects to help me enforce that separation as I code. Let's take a quick look at some of that pure business logic to see what that looks like and then how it integrates with the imperative shell. So let's pull up postlogic.fs because this is where all of the logic around posting comments exists. As you can see, this file is pretty small. It's only about 270 lines. And a lot of that is just spacing and comments that I included for grouping the code. Here again, F# shines. The core business logic for my commenting system fits into this small amount of code. At the top, we model all of the operations that you can perform against this system as types. And if we keep scrolling, we'll see at the bottom of the file, we define a posts module. This module defines all of the business logic and all of the different operations that you can perform. And as you can see, most of these functions are less than 5 lines. If I were using a smaller font, all of this code from this module would probably fit on one screen, which is pretty cool. Let's take a look at how we can use this pure business logic within the imperative shell portion. If we pull up core API and go into posts and then posts actions, we'll see what this looks like. First, I'm defining DTO types that make it more ergonomic to pass in unvalidated data from the outside. Then we define some types to model the output of executing an API. These outputs allow us to provide data as to what changed in the system as a result of the API being executed, like the contents of a newly added comment, for example. Then we define an interface with a function for each of the operations. Yes, you can use interfaces in F#. And then we define a post actions module that implements each of these actions. There's one function on this module called with dependencies, and it takes in dependencies and returns an implementation of our interface using F# object expressions. Let's take a look at the create post action. This action allows me to create backing storage for comments on the posts in my blog, which is necessary because the source of truth for my posts is in the front end. So just taking a look at this, you can begin to see the functional core imperative shell at work. At the beginning of this action, we have some validation that gets done here at the edge of the system. Then we call into our post dependencies to look up if a post with the given information already exists, which our pure business logic needs to make the decision. Then, if we succeeded, we pass that information to our pure business logic to make an actual decision. We've reached the functional core. Once a decision has been made, we need to do something with that decision. If our business logic gives the go-ahead, then we call our dependencies to create the post in our database. Otherwise, we return an error. Now, the last piece of this puzzle exists in the HTTP project, which is the entry point of the application. My main goal with this project, aside from writing F#, was to keep the costs at a minimum. To do so, I wrote this as an Azure function app. This is .NET after all, so we get access to all of the nice frameworks and libraries that we've grown accustomed to in .NET over the years, as well as all of the Azure goodness. Much like my other projects, this one is also fairly small. I'm going to close out of these here. This one is also fairly small. We have a program.fs here that defines, configures, and runs the function app as you would expect. And there's also some other useful helper modules and functions at the root. And then we have our endpoints directory, which is where all the good stuff happens. So let's take a look at that. The main thing here are these directories: blog, admin, and queues. Blog defines public endpoints that the website depends on. Admin defines endpoints that are protected with JWT authentication, and these are the endpoints that my internal Android app uses. And finally, we have queues. This directory contains one queue-triggered function. This function helps support the synchronization of posts from the front end into my back end so that people can actually post comments on them. So let's take a look at post comment under blog, since this code actually wires up and calls one of our actions from core API, and it'll be good to see what this looks like. So at the top, we define a type to model the incoming JSON body. Then we define a class. You heard me right, that's a class that accepts a number of parameters that will get injected via normal .NET dependency injection. We still get access to all of that stuff too, which is nice. Then we define a method run that is annotated with the function's name. We give it an HTTP trigger with a method and a route. Within the method body, we call postDependencies.live, which wires up our dependencies with everything that it needs to do its job, like a table service client, email and messaging clients, and so on. Then we call postActions.withDependencies and pass in the dependencies that we just created to get back our iPostActions implementation. Then all we do is grab the input data from the JSON body, we call the action with that data, and we process the result and map it to an API response to send back to the client. And that's really it. Now, I know that this is quite a lot of code still, but don't worry. All of this code is out on my GitHub right now. So if you want to look at it in more depth, you can absolutely do so, and I encourage you to do so. Let's jump back over to the slides. Next, let's take a look at some of my open source contributions. What I want you to notice is how very unimpressive these contributions are, and that's the whole point. When I started out in software, open source had this sort of mystique around it, as if it were reserved for the elites who write and publish operating systems for free in their sleep or who can hack together a C compiler in 4 hours. This perception kept me from doing much contributing until the last couple of years. I want to try and help that mystique fade so that you can feel confident to get in there and just do something. So here we are with some of my pull requests. Now, a lot of the pull requests that I'm going to show you are to a repo called FS Toolkit Error Handling. This is a pretty popular library and widely used in the F# ecosystem. It also happens to be a great place to start if you want to get into open source contributing, which is why I started here. It's just a bag of functions and utilities. Now, this first PR I decided to open when I was working on a side project. As I was coding, I noticed a couple of helper functions that weren't in this library, and I thought that would make a good addition, so I opened an issue and submitted a pull request. This next one was a product of boredom. I wasn't doing anything one Saturday, and I had lost some of my momentum on my side project. So, to keep myself entertained, I poked around FS Toolkit's documentation and noticed a fair amount was missing. So, I decided to write it up and submit a pull request. This one was also a result of boredom. In this case, I was a little tired of writing documentation, but also didn't want to go back to my side project yet, so I perused the open issues on this repository and saw someone request a feature. So I figured it would be easy enough for me to implement, so I took it and opened a pull request. This next one is the smallest one yet. It's for a different library called FSHTTP, which is a library that implements an F# computation expression for constructing HTTP requests. I've used this library a number of times because it's a really nice library. And one day I noticed that the documentation link in the README didn't work because it was pointing to an old URL. So I opened this pull request to fix it. Pretty easy. Now, I want to give a quick shout out to the person responsible for this library because they are also working on a really cool F# project called Pixel Clock. Pixel Clock is this really cool pixelated clock, and it's programmable using F#. And from the sounds of it, you'll eventually be able to program it with C# as well. So if you like tinkering with hardware and writing F#, this project is definitely something that you should check out. Now, this last PR that I want to show you is the most recent one. At work, we have a functional programming channel within our teams. We have a few blogs that feed directly into that channel whenever new content gets posted. We do this via workflows and RSS feeds. I wanted to add a workflow to get alerts whenever the folks over at Amplifying F# posted any new content. Amplifying F# is a great community-driven F# initiative. I poked around their website, and as it turns out, they didn't have an RSS feed. I happen to know that their blog uses Astro, and my blog had RSS configured out of the box, so I figured it wouldn't be super difficult to implement, which it turns out it isn't because Astro has a plugin for that. So I opened an issue to see if they were interested in the feature, and they said go for it. So I opened a pull request, which has since been merged, and now their site has an RSS feed. And that's all of the open source contributions I wanted to show you. let's jump back into the slides and finish up. Before we finish up, I'd like to make a dedication. I'm dedicating this talk to my brother-in-law, Ben, who passed away suddenly at the end of September. This is the same Ben who bought that first generation iPod Touch all of those years ago that started my fascination with mobile apps, which is ultimately what kickstarted my love of software development as a whole. He is a big reason that I even am where I am today, and I miss him a lot. So I wanted to honor his memory with this talk. With that, finally, we have some links that you can access. These slides will be made available to you. That top one is my blog. The next one is my GitHub. Then I've got my company website there. Below that, we have the Amplifying F# website. I highly recommend that you check them out. And then the last one is an invite to the F# Discord, which is a great way to get connected to other F# developers in the community. And with that, thank you for coming to my talk.